Hello and welcome to the Mizzou Engineering 2021 Engineering Week Lab exhibits. Unfortunately, we cannot be doing these presentations and these activities with you all in person, but we hope that you enjoy our presentation. So today we're going to be talking about what industrial engineers do, and we'll be talking about simulation software. So to start, what is an industrial engineer? An industrial engineer is someone who applies science, mathematics, and engineering methods to solve problems and make systems more efficient. They're concerned with saving money, time, resources, and much more. And the goal of every industrial engineer is to find different ways to make things better. And at times there might not seem like there are ways to make different systems, processes or anything like that better. But that's why there are industrial engineers, because you're always looking to make little changes that result in big saves and successes within a company.
So what is simulation? Simulation is the imitation of a real-world process or system over time. We can create models of real-life places in a virtual world to see how things work or how they will change if adjustments are made. So you can simulate a lot of different processes. At the top here, it's a simulation of a bridge. So people like civil engineers would work with that. In the middle simulation, shows how much stress would be put on a piece of equipment if adjustments are made. And at the bottom, there's a plant where simulation is used to see if processes can be changed to create more items, to increase utilization or whatever your goal might be. So it can be used in a wide variety of areas.
So what's the point of doing simulations? We use simulations to understand the current day-to-day operations and to investigate a wide variety of what-if scenarios about real-world systems. Some examples include, what is the impact of a new runway at an airport? How is that going to affect how often planes can take off and land? How is it going to impact the speed of adding another drive-through line at Chick-fil-A? Or what about putting moving equipment to a new location? How is that going to help the overall factory work better?
So why is simulation important? Well, it's important because modeling real events in a virtual world to determine the impact allows us to just kind of see how things are going to change. It allows us to save a lot of money trying new strategies virtually before making real changes. Because if you just say, oh, this might work, and then make a big change within a manufacturing facility or adding a drive-through at Chick-fil-A, for example, it could be really expensive and it might not help your system at all. Then it can also show us where process bottlenecks are. But what a process bottleneck is, it's an area of a production process or any kind of system where things slow down. For example, in this picture here, I'm sure we've all been in traffic before and there's been an accident and we've had to merge into one lane or two lanes. And that would be considered a bottleneck because instead of going 60 miles an hour on the highway, you are now slowing down and doing 10 miles an hour. And the same thing happens in manufacturing facilities, for example, where you have these bottlenecks and you need to figure out how you can avoid them and make things merge better.
So simulation is used in a lot of different areas, and a lot of companies that you might buy from on a daily basis can use simulation to help their business grow. So anyone like manufacturing facilities, hospitals, airport, restaurants, stores with checkout lines, so Walmarts, Targets, grocery stores, etc. Different offices, so think of driver's license offices, doctor's offices, and even concert or sporting event ticket scan lines will use simulation to help speed up their processes.
So different simulation softwares look different. A really popular program that industrial engineers use to simulate different models is called Simio. This is the picture that's down on the left-hand corner of your screen. In any of these softwares, you can make 2D or 3D models. So it can be just like a flow chart, which would be 2D, or like the pictures you see here, it can show you actual people moving between different stations or actual planes moving on the runway, and that would be a 3D model.
So how do industrial engineers work with simulation software? Well, they're able to see the outcome before spending lots of money, which is important because if you take a risk not knowing how it's going to change things, it could really mess up your process, and then you have lost a lot of money. You have to make another change and come up with another solution to make that money back. You're able to input real times and distances of a facility, for example, a manufacturing plant, to see how products and people would travel between different stations and understand how long it should take to finish different tasks. And then we can also use simulation to determine how the current system should be performing and if it is doing so, because there are multiple times where you can input data and see, oh, we should be making 100 products per hour, but in reality, you know you're only making 80. So then you can determine, oh, we need to fix this, which will allow us to be reaching our goals. Then we can also use simulation to practice queuing theory.
Queuing theory is one of the studies that industrial engineers use that is closely related to simulation. It is a mathematical study of waiting lines or queues. It's a powerful tool for designing and evaluating performance, and it's a decision maker has to decide between trade-offs. So queuing theory is the study of the people waiting in line, as you can see at the picture on the right. When a customer arrives, they have a few different options. When waiting in line, first they can balk, which means they leave because the line looks too long. While they're waiting in line, they can do what is called jockeying, which just means switching between lines to whichever one is shorter. And lastly, rummaging, which is when you first wait in line, but you leave after realizing it's taking too long.
So now it is time for an example to show you all how simulation is actually used. So the game or the example that we have put together for you all is called Hurry Up and Wait. So as we said, we study different lines and we want to understand how people flow between lines and how fast that lines move so we can make them more efficient so that people are not waiting as long. So we have put together a simulation in Simio that shows a office where people are working with different desk attendants and getting some paperwork scanned. So one of the stations will be one big line with two different stations or servers, as we call them in simulation. And then on the right side, as you will see, will be two separate lines with two servers. And we're going to see which one moves faster and gets more people through and is therefore more efficient. But before we show you that, thank you for watching the presentation. The example will be coming right up. If you have any comments or questions about simulation, please feel free to leave a comment on the video and we will respond to your questions and comments. Thank you so much for watching.